Hello everyone. So today we will continue our tutorial about Linebuffer, tutorial number 2. We stopped at this point. Buffer with inputs, clock reset, valid and read data as input, and output is output. That means we input at each clock data 8 bits and we output 8 bits. We have done the simulation manually, but now we are going to make it automatically by setting a test bench. We have with line buffer of 6 values. Now we'll try to declare a test bench. We'll create a source, create file. We will call it image line buffer bench. In which we'll input 6 bytes, and we output the 6 bytes one by one, but in this time automatically. It means using the test bench, because usually we need to use test bench to be automatic. We cannot every time do it one by one, especially if the data is too big, for example 512 pixels or more. First thing is to declare, of course I don't like these comments. First thing is to instantiate the line buffer. We put it in the test bench because this is what we are going to test. So we remove all these things because we are going to instantiate it. We call it, for example, buffer, and we remove all this to do or create a report with the corresponding variable coming from the outside world. So we do it one by one. Okay, data, not 3 pixels, we are going to do this later. Now we're just going to understand how it functions byte by byte. So we need to declare a clock as input. Also we need reset for initialization and for starting the operations. Then we call it, for example, image data. Why image? Because later we are going to use pixels, means the data of pixels of image. Data valid, to make sure that the data is valid. This is the image data that we call output. Or of course we need this flag for enabling the data. Now of course we need to declare all these variables, otherwise it will complain. So by clock, of course, reset the image data 7 down, sorry about this, 7 down to 0 of the image data valid, image data valid. What else? Our data, the output 7 bits in this case, out data, and reg data or read data. Okay. With this, normally it should be okay. Now we start the simulation. There's a mistake here. Okay, we start simulation. Of course, we need is the initial. First thing to declare the clock. Clock will be initiated to then begin. And what should we be doing is to we should inverse it, so we need to import this time clock. This way we are generating our clock. Now we start the initial begin and so first thing is to put reset to 1, image valid 1, then we wait some cycles in order to do the reset for 0 to start the code, make it run. Now we need, of course, this image data. From where we are going to get this data, we need to declare a matrix. So before that, we need to initialize we declare first this matrix. This is how we Verilog, a matrix of bytes we call image, like this image, or just we call it image. It will be composed of 5 elements. So we have 5 elements of image, for example. We need to fill these images one by one. So image 0 equals, for example, 1, just to make it simple. And we make the thing from number 0 to number 1, 2, 3, 4, 5. 1, 2, 3, 4. So this is our image. We need to change data just to explain more. 1, 2, 3, 4, 5, and 6. So this is our data. Just put it like this to make it simpler. Okay. There is a mistake here. We need to give it the size like this. Okay. Now, once the image is filled or initialized, we'll start reading from this image one by one. So we call it image data equals which one we need to put something like that. A loop for from 0. You will notice that it looks like C coding, which is beneficial for us. Time will input image data or read from the original image this byte, which means if you remember, each time we read the data, we need to say that it is valid, otherwise it will not be taken into account with the IP. So each time we will make it. Now we need, of course, to declare the I, integer I, because we are just counting from 0 to 5 of the data. Here we have problem because we didn't put comma. Everything looks alright. When we fill all the data, and each time, of course, it's input here, the image data, it's giving out the out data. So we need to wait for the to the next clock, positive edge of the clock. Yes, I forgot something here. We need to fill it one by one, each cycle. We need to wait for each iteration of the loop. We need to wait for the clock, positive edge, and to fill. So in one, it means to make it more visible. Then when we finish, we do the image data valid equals assigned 0 to say that the data is more valid. And we wait for another positive edge to start reading. But to start reading, we need to make this one equals to 1. Everything looks fine. So if you remember from last tutorial, we need every positive edge of the clock after, of course, resetting and starting. You need an image, read an image data from the source, make sure it is valid. When we finish all the data, we need to start reading, allowing it to make one. We'll start and we'll see if it is working fine or not. So we start by simulating, run simulation. I made a mistake because I used to do some simulations, of course. We'll change this one. Choose the top level and okay. Now we'll simulate and see if you are okay or not. Run simulation. Okay. Alright. We'll start the simulation. It looks we have a problem in the code. We'll check. We'll go to PC console and we start from the right. Concrete assignment outdated. Okay. So we have a problem with this. Okay, it shouldn't be rect, it should be wire because we are reading and writing from it in the same time. So we correct this mistake and we do the simulation. Okay, so as you notice, the test bench, as soon as we start running, we will see the results. So this is becoming automatic. We'll check if it is running okay or not. We start from the image, we check if it's reading okay. So cycle from 1 to 5. Then when the rate data is equal to 1, we have a problem, we are not reading out of data, we need to check what is the problem with it. Okay, we have a problem, the data is not coming out, it means we have a problem. When we read the data, we need to give it some time, so each cycle it will read the new data. It means here we need to set a process at each positive edge we need to read the data. Begin and okay. We say if reading data second, and we should for example receive data, we should start incrementing this variable equals same 1 plus 1 and we count. Now if this received data has reached, well, we have from 0 to 5, it means 6, we stop simulation and we check, stop with this sign. Of course we need to begin and begin. Of course we need to declare this. as integer because just counter integer. We should start from there. If it's okay or not. If the changes and we'll wait.